A sector is a wedge-shaped portion of a circle. Both the area and the length of the arc can be expressed most easily using radians. So this is one of the reasons why radians exist, because when we're trying to find area and lengths of sectors, these are most easily done with radians. So let me first draw a sector. If we have a circle, I'll start with a circle. If we have a circle and we cut out a piece like this, and then I just throw this stuff away, then what's left is a sector. And this angle, whatever angle I say here, I'll call it A, that angle, if I express that measure in radians, then I can find the arc length, that is this distance here, the length of this arc, this part right here. I can find that arc length just by taking r, which is the radius, times a, the angle expressed in radians. Similarly, I can find the area of this sector, this whole area here, by taking 1/2 times r squared times a. Again, as long as a is expressed in radians, I don't have to do anything beyond that. All right, so a sheet metal worker wants to know what the arc length and area of a sector with a central angle of 150 degrees is, cut from a circular sheet of metal with a radius of 16 inches. So he has, we have a metal worker here that has a circular sheet of circular piece of sheet metal, and this is 16.0 inches. That's the radius. We're taking a 150 degree angle cut. So let's see, 180 would be there. We'll say like there. That looks like approximately 150 degrees. My cat is being buggy. Alright, so the sheet metal worker wants to know the arc length, so this distance right here, and the area of the sector. So one of the reasons you might want to know something like this is if you then rolled this, you could create a cone really easily, and this arc length right here would be the circumference of the resulting cone. You know, if you were to take this to be the point of the cone and roll it up, you would end up having something that looks like this. This distance right here would be this arc length right there. And the area, well, that would tell you the total weight of this thing. Probably you could use that to find the total weight of this thing. All right, in any case, that's why you might want to do something like this. Let's actually do it, though. We know that the arc length, S, is equal to r times a, so the radius is 16. The a is 150 degrees, but of course, in order to do this, degrees don't really cancel out very well. They don't just kind of go away. When we're dealing with radians, it's kind of a non-unit. This a is intended to be a unitless ratio or unitless thing. So this 150 degrees is not unitless. This degrees is definitely a type of unit. So what I'd want to do is say, okay, well, I'm going to cancel out 180 degrees with pi radians up here. So that means the degrees will cancel with the degrees, and the radians kind of go away. They're not really a unit. So I can just do this. I can do 16 times 150. That's 150 degrees, but converting that degrees to radians means multiplying it by pi and then dividing by 180. So this gives me 41.887. Round to 3 significant digits. So 41.9, it looks like. That's the third digit there. 41.9, and we're talking about, what are our units here? This is an arc length. This should be inches. That'll be about 41.9 inches. As far as the, what is the area? I'll use that formula out there. Area is equal to 1/2 r squared times a. Again, a needs to be measured in radians. So we get 1/2 times 16 squared times 150 degrees. Converting this to radians, I'll go again times pi radians divided by 180 degrees. So let's go 0.5 times 16 squared times 150 times pi over 180. I could do the 150 times pi over 180 in parentheses like I have it written, but it actually doesn't matter, so I'm not going to bother. We're rounding this to 3 significant digits again, so 335. And this is, it looks like an area, so this will be 335 square inches.